This video is on collecting like terms, and in the lesson so far we've already talked about what like terms are, but I'm quickly going to recap as it's quite important that you understand this. So like terms, what we need, it's like a little ingredients list. We need the same variable, and another word for the variable is a pronumeral, or even more basically just a letter. So we need the same letter, and we also need the same power, and as long as you have those two things, you have like terms. For example, 6m squared, so the variable is m, the power is 2, and minus 5m squared, we've got some like terms. It's supposed to be a tick sign. If I have 4ab and 9ba, we've got like terms because we know with multiplication the order doesn't matter, so ab is the same as ba. If I have 12a squared b and 8ab squared, it looks like we have the same letters because we have a and b in both terms, but in this term the a is being squared, and in this term the b is being squared, and that is not, these are not like terms. So in order to have like terms, the power needs to sit with the same letter. So if I wanted to have a like term, say with this particular term here, I could have 8 or minus 8. I could have ba squared, because remember the order of the letters doesn't matter. With multiplication we can multiply in any order. So, but here I have a squared just like I do over here, and so these two terms, so this one here and this one here, these would be like terms, but the third one is not a like term. So just make sure you understand that. Whoops. Alright, so let's do a few examples. I think collecting like terms is straightforward as long as you do this one particular step, and it is so important because even the best students will make mistakes when they don't do this. I want you to circle the like terms. So in this example I can see I've got a 5p here and I've got a plus 4p. The sign always goes with the term that's immediately after it. So when I circle it, you must include a sign with every term. Okay? And then I can see I've also got like terms over here of minus 7q and minus q. And once I do that, I think it's much easier not to make any simple errors. So if I have 5p's and I add 4p's, then I would have 9p. And if I have minus 7q and I minus another q, and when we're talking about minusing another q, there's no number there, but we know that if there's no number, we're really just minusing one q. So if I have 7 q's and I minus another q, then I would have minus 8q. So the error that I often see is students will ignore that sign there, and they'll just add or subtract, but they won't pay attention to that minus, and that will lead to error. So please, I'm going to be checking all of your work to make sure that everybody's heeded my advice and that you're circling each term with the sign in front. Let's try another example. Here we've got some like terms. We've got 5a squared, and we also have minus 10a squared because we can see they have the same letter and the same power. And I've got minus b squared and plus 3b squared. So let's combine our like terms. So we've got 5a squared minus 10a squared. So we're talking about a squareds here. So students will often change the powers when they're adding and subtracting, but we don't. In this case, we're talking about a squared. If I had 5a squareds and I took away 10a squareds, I would have minus 5a squareds. I'd go into the negatives because I'm taking away 10. Now, this is the example that I was talking about before. If students don't pay attention to signs, so for example here, they just take the b squared and they add the 3b squared, they'll say, oh, it's minus 4b squared. I'm going to write that down. Minus 4b squared. That's actually wrong. Okay? And it's really important that you can see in this example that I'm not taking b squared and adding 3b squared. I'm actually taking minus b squared and adding 3b squared. And that makes a really big difference to the answer. So let's get rid of the error and fix it up. So if I take minus b squared, and I definitely will put in my 1 to remind myself, if I take minus 1b squared and add 3b squared, so we've got minus 1 plus 3, then I would have positive, minus 1 plus 3 is positive 2, and I'm talking about b squared, so I don't change the powers, we get plus 2b squared. And that is the perfect example of why you circle every term and include that sign, because if you ignore that sign, you will end up with an incorrect answer. Alright, here's one for you to do. So this is where you can pause the video, give it a go, and then start it again or press play when you're ready to compare your answer to my answer. I'm going to go straight into answering the question. You give it a go, press pause, give it a go, and then restart the video. So let's circle our like terms. We've got f cubed over here, whoops, f cubed over here, and minus f cubed. Notice that I've taken the minus sign with it, and then I've got minus 11n squared and minus 4n squared. So if I have 10 f cubes and I minus 1 f cubed, I still will have f cubes. I'll have 9f cubed. 9f cubed. And if I have minus 11, not 11, but minus 11n squareds, and I take away 4n squared, so minus 11 minus 4, that would be minus 15n squared. And that's the answer. I can't combine the f cubed and the n squared because they are not like terms. So that's the end of the question.